Good morning. Today we will discuss different types of laser. Based on the type of active medium and the laser system are classified into following categories. That is based on the lasing material. Lasers classified into the following categories. First is solid state laser. Examples are ruby laser and NT-YAG, that is neodymium YAG laser. These are two examples. Next is gas laser, helium neon laser, carbon dioxide laser, argon ion laser. The next is liquid laser. There are europium chelate laser and SeOCl2 laser. Next is dye laser, rhodamin 6G laser and coumarin dye laser. Next is semiconductor laser, gallium arsenate laser and gallium arsenate phosphorus laser. In this, some of the laser have to be discussed in our syllabus. In solid state laser, we have to discuss ruby laser and ND-YAG laser. And in the gas laser, helium neon laser have to be discussed. And then we have to discuss the semiconductor laser. So we have to discuss 4 lasers: ruby laser, helium neon laser, then neodymium YAG laser and semiconductor laser. So today we discuss ruby laser and helium neon laser. First we go to the ruby laser. The laser action was first reported in ruby by Mayman in 1960. And both the technique and theory have since been extensively developed. The first laser made by Mayman, that is the ruby laser. It is in 1960. And the ruby laser is made from ruby rod. It is grown from sapphire. It is aluminum oxide doped with 0.01 to 0.05 percentage chromium by weight to form a synthetic ruby crystal colored red or pink. So ruby rod is made from sapphire, that is aluminum oxide doped with chromium by 0.01 to 0.05%. Here chromium is used as impurity or to create a metastable state. Okay. The ruby rod is a crystal of aluminum oxide, so that some of the Al3 plus ion are replaced by chromium ions, Cr3 plus ions. For that, we added the impurity chromium. Okay. And the rods are up to 20 centimeter long and 3 to 2.5 millimeter in diameter. Look at the picture. It is the ruby rod. Okay. And the ruby resists the optical damage at normal power level if its surface is clean, and its conduct heat better than glass. The ends of ruby rods are optically flat and parallel. The rod is surrounded by a glass tube. Look at the figure. It is surrounded by a glass tube and the rod is wound a coiled flash lamp filled with xenon gas. Xenon is which type? It is xenon have the outermost shell is completely filled, or it is an inert gas. Here the xenon flash lamp is acting as the optical pumping system. The impurity chromium ion give pink color to the ruby and give rise to the laser action. Okay, and the energy level of the chromium ion is shown in figure. Okay, Here, look at the figure. First, we discuss a general case of an optical cavity. So, in this figure, this is the ruby rod and this is the xenon flash lamp is mounted on the ruby rod, and here two mirror kept parallel to the rod, and here the left mirror is completely silvered and the right mirror is partially silvered. Okay, then for every laser active medium this method is using. In the case of gas laser or in the solid state laser, we use this mirror cavity. Okay, it is used for the optical amplification process. In this figure, the energy level diagram is shown. Okay, we will come to the energy level diagram later. So we continuing our working. Here, when looking at the energy level diagram, this is E1, this is E2, and this is E3. Okay, and first we discussing the operation of this laser. So by the laser we means light amplification by stimulated emission of radiation. Okay, and the laser action to occur, there must be a metastable state and population inversion must achieve, and also the light amplification must achieve for getting an intense beam. So here ruby rod is the active medium and we added chromium as the impurity. The level of chromium will be the metastable state. It is a level E2. Okay, E2 level is the metastable state. Then here E3 is a short-lived state. That means the lifetime is very short there, and be giving the optical pumping with xenon flash lamp. It gives a frequency or energy corresponding to 550 nanometer. Then the atoms goes to the energy level E3. As it is very short-lived, by a radiationless transition, the atoms going to the state E2. As it is a metastable state, what happens? As it is metastable state, the atoms stay there for long period. Okay. So by the continuous pumping, the number of atoms in the energy level E2 increases. So the number of atoms in the energy level E2 increases by some times. N2 will be greater than the atoms in the lower level. Then the population inversion must be achieved. Okay. Then there must be chance of stimulated emissions and spontaneous emission. Let us consider any spontaneous emission. Spontaneous emission means that it occurs without any external triggering. Okay. Only one photon is emitted. Okay. Then consider that by spontaneous emission, a photon is emitted. Let us consider that photon move to this mirror or this mirror. Okay. If it is moving in this mirror, it is reflecting back. This photon hit here and reflecting back. Then it may hit any of the excited atom in the energy level E2 because of the atoms in the energy level E2 is very greater when compared with E1. That is N2 is very greater than N1. So the photon coming from the mirror may hit the atoms in the excited state. So stimulated emission may occur. The atom in the excited state absorb these photon and de-excites through stimulated emission by releasing two photons with the same wavelength, 694.3 nanometer. Okay. So then a photon is converted into two photons. Then this photon move through this rod and hitting at this mirror. It may reflected back. The two photons reflected back into the active medium and may hit on two different atoms. Okay, and the two atoms may be absorb the corresponding photons, then they de-excite through stimulated emission. Then each atom emits two photons, then a total of four photons. Then the number of photons increases. Okay, first only one photon, one h nu. Okay, and it is converted into 2h nu by the stimulated emission by one atom, and each h nu is converted into h nu, and this is h nu and h nu. So in this way, 1 2 4, then 8, then 16, then 32, etc. The photon multiplies. Okay, photon multiplies means photon is light is increased or it is amplified. Then light amplification occur by what process? Stimulated emission of radiation. Okay, then the number of photons increases. That means the intensity. We know that by the number photon increases means the intensity of light increases. Then a intense beam will emerge through the partially silvered mirror. It will gives as the output. Okay, this is the working principle. So it is about the energy levels. Ruby laser is a three level energy system. The lower energy E1, then middle energy E2, which is a metastable state, and E3 is the higher energy. Then the difference between E3 and E1, it is E3 minus E1, that is nu, that is equal to corresponding for 550 nanometer. And then that pumping we used is xenon flash lamp. Okay, and the metastable state E2 has a lifetime of 10 raised to minus 3 second. Okay, its lifetime is 10 raised to 5 times greater than the lifetime of E3. E3 is a short lived state. Okay, it is working. Usually most of the chromium ions are in the ground state, and the flashlight is falls upon the ruby rod. 550 nanometer radiation photons absorbed by the chromium ions, which are pumped to the excited state E3. It is optical pumping. Okay, the excited ion give up by collision part of their energy to the crystal lattice and make a transition or decay to the metastable state. By the optical pumping, the atoms goes to E3. E1, from E1 they go to E3, and it is by optical pumping. optical pumping, and from E3 to E2. It is downward transition de-excitation, or it by non-radiative transition, or it by collision with the crystal lattice. Okay, then E2 is a metastable state. And now the atoms is reaching at E2, and E2 is a metastable state, or its lifetime is longer, then the number of ions in this state goes on increasing, and that on E1 decreasing. So N2 increases and N1 decreases. So population inversion achieves. Okay. When an excited ion passes spontaneously from metastable state E2 to the ground state, it emits a photon of wavelength 694.3 nanometer. Okay, this photon travel through the ruby rod, and if it is moving parallel to the axis of the crystal, it is reflected back and forth by the silvered mirrors until it stimulates an excited ion and causes it to emit a fresh photon in phase with the stimulated photon, or it induces the spontaneously emitted photon induces another ion for stimulated emission. Okay, this stimulates the transition for is it laser transition. Transition 3 and transition 4, that is given in the figure. Okay, so we call it as transition 3 and they are marked in the figure. And if a photon emitted spontaneously which do not move axially will escape through the sides of the crystal. The process is repeated again and again, because the photon repeatedly move along the crystal being reflected from its ends. So the light amplification, or the photons, thus multiply. When the photon beam becomes sufficiently intense, a part of it emerges through the partially silvered end of the crystal. Okay, and now the drawbacks of the ruby laser. In this laser requires high pumping power, because the laser transition terminates at the ground state, and more than one half of the ground state atoms must be pumped up to the higher state to achieve population inversion. Moreover, the ions which happen to be in the ground state absorb a photon with wavelength 649.3 nanometer from the beam, and as it's built up. And the next drawback is the ruby laser is a pulsed laser, because the active medium chromium is excited in pulses. The flash lamp flashes. When the flash lamp flashes, the active medium excites with that flash, and from that a laser pulse is emitted, and there is a gap between different pulses. So ruby laser, the output of ruby laser is a pulsed one. It is not continuous. While the xenon pulse is of several millisecond duration, the laser pulse is much shorter, less than millisecond duration. It means enhanced instantaneous power. Next is the gas laser, helium neon laser. This is the transition 1 in the ruby laser, and this is the transition 2, and this is transition 3, and this is the transition 4. Then transition 1 is the pumping transition. It is induced absorption. And transition 2 is radiationless transition. It is occurs by hitting of ion with the crystal lattice. It is non-radiative transition. And the third is spontaneous emission. And the fourth is stimulated emission, or it is the laser transition. The next is the helium neon laser, and we will discuss helium neon laser in the next session.